Hi everyone, this is video 4 for chapter 3.1 or section 3.1 and 3.2. So we just finished up using models to add whole numbers. So now we're going to transition to using algorithms to add whole numbers. So what is an algorithm? So an algorithm is really just a step-by-step procedure. I think a really tangible example of this is a recipe. So whenever you follow a recipe, you follow a step-by-step procedure and you come out with this delicious food that solves your problem of being hungry, right? So we use these all the time, right? We're given step-by-step instructions. So any of those are just an algorithm. These are really common in math, but also in computer science. Your computers run on algorithms. So we have two different algorithms that we're going to talk about for addition. So the first one is the expanded algorithm. So this is an algorithm that tells us how to use or how to add two numbers. So let's go through it. So this says to first write the numbers vertically, lining up the digits by place value. So we're going to take a 4 and a 3 and a 2. And then we're going to write our, this is base 5. Then we're going to take our 3, and our 4. This is also base 5. Okay, so we lined our digits up and we are adding them. Okay, so now it says to add the digits in each place value position. So we can do that in any way we want to. So this, we can start right to left or left to right because we're just adding them each by place value. So one other way that you may want to write this is that we're doing 4 flats, 3 longs, and 2 units, plus 3 flats, 3 longs, and 4 units is another way to write this. Okay, so let's go ahead and add the 4 and the 3 first. So when we add 4 and 3, we get 7, but since we're in base 5, we really just get 2 and we carry the 1. And so since we're adding the 4 and the 3 over here on the left, then we just fill in zeros everywhere else. Okay, so next let's add the 2 3s. So when we add 3 and 3, we get 6. So we really get 1 and then another 1 over here in the next place value, and everything below it is 0. And then when we add 2 and 4, we get 6. So we have 1 and then put another 1 over here. And now we add all of these up. So whenever we add all of these up, we get 1, 2, 3, 1. So we get 1, 3, 2, 1, base 5. Okay, so we can do it this way. So if we did it over here using the other way, we would get 7. We would get 2 flats and 1 left over, and then we would get, we would get 6 longs. So we would get 1 long and 1 flat. And then over here with the units, we would get 6 units. So we would get 1 unit and 1 long. So this way is a little bit more confusing because you know what you have, and we don't really have a word or bigger than a flat that's easy. I guess a block is what I would say. That is what is natural to me, but I'm not sure. Well, I guess that's a little bit hard because these are all blocks. Yeah. So we have these ways to do it. I'm going to go ahead and erase. Oh, sorry. I'm going to go ahead and erase this one over here. So we have this expanded algorithm. So we get 4, 3, 2, base 5 plus 3, 3, 4. Base 5 is 1, 3, 2, 1. Base 5. Okay, so the expanded algorithm is really nice because it reinforces place value, first of all, because we add things that are only vertically above each other, right? Each place value of each number is vertically above each other. So it reinforces that place value, but it also can be worked left to right. So you see that we added 4 and 3 first. So a lot of mathematics is worked right to left, which is opposite than we read because we read left to right. So this is nice because, mostly because it reinforces place value. But this is a lot of steps. So now let's go to the standard algorithm. So the standard algorithm, again, we line everything up. We write it in the exact same way. So now we're adding 2, 3, 7, base 8, and 6, 6, 5, base 8. And we are adding these together. So the standard algorithms essentially says we do the same thing, but we have to start in the units. So if we add 7 and 5, we get 12, which has 4, and we carry the 8 over. So then we have that one group of 8 was made, so we carry that 1. So then we add 1 plus 3 plus 6 is 10, which has one group of 8 in it that we can take out, and 2 left. And when we add 1 and 2 and 6, we get 9, which has one group of 8 and 1 to carry over. So we do it like so. So this is the traditional way that we do addition, at least the way I learned to do addition when I was in school. So we have that my apologies again, 237 base 8 plus 665 base 8 is 1124 base 8. Okay, so now let's talk about what are the pros and cons with this expanded versus standard algorithm. So we noticed that definitely just in writing them out, that the standard algorithm is a lot shorter. So let's write down standard algorithm and expanded. So yeah, the standard algorithm is shorter and more compact. There's less writing. But they don't have to think about place value. That was one thing we said. So this is shorter / compactor. But one thing about the expanded algorithm is it reinforces that place value. So because you add things only in their specific place value. So it reinforces place value. And another pro to the expanded form is that you can work the problems left to right, the way that we read. So we can work the problems left to right, whereas the standard algorithm, you have to work it right to left, which is a little bit backwards. But one thing about the standard algorithm is that this mirrors the base blocks, right? We regroup the units, so this mirrors the base blocks. So this mirrors, right, the base blocks because we regroup the units and then we regroup the longs and then we regroup the flats. So we regroup our smallest to our largest. And so this is really similar to the base blocks. Okay, so those are the two algorithms we're going to talk about for addition. So that should be all for addition. So that's all from section 3.1. You can see next time we're going to move to subtraction, which is in section 3.2. So that is all for this video.